Hello students, welcome back to the classroom point. In our today's class, we shall discuss the balancing of redox reactions. In our previous classes, already we discussed what is oxidation, reduction, and how to calculate the oxidation number, and how to balance the reactions that we shall discuss in today's class. So let's begin the class. Balancing of redox reactions. So this balancing of redox reactions can be done in two methods. There are many methods, but we use the two methods in balancing of these redox reactions. They are, the first one is oxidation number method, and the second one is ion electron method. This ion electron method is also known as the half reaction method. So now let us see how to balance the redox reaction using the oxidation number method. So here it is. The first one is oxidation number method. Usually redox reactions are balanced in acidic medium as well as in the basic medium. Acidic medium, basic medium rules almost the same, only they differ in the balancing of the hydrogen. So let us see both of these methods, that means oxidation number method in both acidic medium as well as in the basic medium, by taking some examples, and simultaneously we shall discuss the rules also how to balance these reactions. So first one is balance the following reaction in acidic medium. So the reaction is here Cr2O7 2- plus sulfite ion SO3 2- gives Cr3 plus sulfate ion. This reaction has to be balanced in acidic medium. So let us frame the rules. What are the basic rules here? Rule number 1 is always assign the oxidation number of every atom in the given reaction, whatever the redox reaction is given. So in that redox reaction we have to identify the oxidation state of every atom. So let us see here the oxidation state of the chromium. Oxidation state is +6, oxygen is -2, sulfur is +4, oxygen is -2. Anyhow, chromium is given here directly, that is 3+, sulfur +6, oxygen is equals to -2. So first step is completed, that is assigning the oxidation state of every atoms in the given redox reaction. And second one is identify the elements whose oxidation state is changed, and balance them. So we have to identify whose elements oxidation state is changed. Look at this side here, chromium oxidation state +6 +3 means the chromium oxidation state is changed. And sulfur oxidation state +4, +6. Sulfur oxidation state also changed. So we have to identify the atoms whose oxidation state is changed and immediately balance them. Here 2 chromiums are there. Here only 1 chromium is there. So that balance these chromiums first. Sulfur oxidation state is changed, but they are in the balanced position. So not necessary to balance the sulfurs. Already equal number of sulfur atoms are there. Next, third point or third step. Find the number of electrons lost and gained. Equalize them. So here, how many number of electrons are lost and gained? Look at this side, chromium oxidation state changed. From here to here. Change in oxidation state is 3. Like that, how many chromiums are there? 2 chromiums are there. So into 2 equals to 6. Sulfur oxidation state changed by 2. Difference. How many sulfurs are there? Only 1 sulfur is there. So here it is chromium oxidation state decreased from +6 to the +3. That means it gained the electrons. So gain of electrons, how many here? Gained electrons. Totally 6 electrons are gained. And sulfur oxidation state +4 to +6 increased. Means it lost the electrons. So loss of electrons. How many are there? Only 2 are there. But here, find the number of electrons lost and gained and equalize them with a proper number. So the number of electrons lost must be equal to number of electrons gained. So here, only 2 electrons are lost. So it has to be multiplied with a proper number, that is 3 here, to make the loss of electrons equals to gain of electrons. So that here 6 electrons are lost. So to equalize the loss of electrons equals to gain of electrons, we used the number, that is 3. So that the same number we have to use to multiply these values wherever the loss of electrons are involved. So that here in this area 3 and 3 we have to put. And step 4, balance the oxygen by adding H2O molecule. So let us try to count the number of oxygens on both sides. Here 7 oxygens, 3 into 3, 9. 9 plus 7 is equals to 16 oxygens are this side. Here 3 into 4, only 12 oxygens are there. So this side deficiency of the oxygens are there. How many are there? 4 oxygens are less. So add the 4 water molecules. So number of oxygens equals number of water molecules. Why? Because each water molecule bring only 1 oxygen. So that here we have to add 4 H2O molecules. So oxygens are balanced. Now balance the hydrogens by adding H plus ions on hydrogen deficiency side. Since we are using in acidic medium, we have to balance the hydrogens only by adding the H plus ions. Which side we have to add means whichever side less number of hydrogens are there, that side only we have to add the hydrogens. Look at this side there is no hydrogens. Here 4 into 2, 8 hydrogens are there. So that this side you add the 8 H plus ions. So the reaction becomes now Cr2O7 2 minus plus 3SO3 2 minus plus 8H plus gives 2Cr3 plus 3 SO4 2 minus, 4 H2O molecules. And the last step is check the charges or else equalize charges. So the last step is not the balancing, only to identify whether the charges are balanced on both sides or not. So let us check here. 2 negative charges, 3 into 2, 6 negative charges. So 6 and 2, totally 8 negative charges this side, means minus 8, and here it is equals to plus 8. So the total charge on the left hand side is equals to 0. And right hand side, 2 into 3 equals to 6 positive charges, 3 into 2 equals to 6 negative charges. So this side also 0 charges. So 0 and 0, so the reaction is completely balanced. So here we used the acidic medium. Let us take the basic medium, and basic medium, all these rules are same except the fifth rule where balancing of hydrogens. Let us see that now. Balance the following equation using oxidation number method in alkaline medium. So the given reaction is MnO4 minus plus Br minus gives MnO2 plus BrO3 minus. Same rules we have to apply here. What is the first rule? Assign the oxidation number of every atom in the given reaction. So let us see the oxidation number. Manganese oxidation state is plus 7, oxygen minus 2, bromine minus 1, manganese plus 4, oxygen minus 2, bromine plus 5, oxygen minus 2. And rule number 2, identify the elements whose oxidation state is changed and balance them immediately. So let us identify the elements whose oxidation state is changed. Manganese plus 7 to plus 4, changed. Bromine minus 1 to plus 5, changed. But here not necessary to balance, already the atoms are balanced position. So that let us go for the third rule. Find the number of electrons lost and gained and equalize those electrons. So here let us see number of electrons lost and gained. Manganese oxidation number decreased, means it gained the electrons. What is the difference in oxidation state? It's 7, here 4, 3 electrons difference. So it gained electrons equals to 3. Similarly, bromine oxidation number increased, minus 1 to plus 5. So that means it lost the electrons. Loss of electrons equals to how much? 6 electrons. That means minus 1 to 0, 1 electron, 0 to 5, 5 electrons, totally equals to 6 electrons. And here what other thing is there? Equalize those electrons. So we have to equalize these electrons with these electrons. Gained electrons must be equals to loss of electrons in any redox reaction. So this value has to be multiplied with a proper number that brings equal electrons. So which number we used here? 2 is the number that we used to equalize these electrons. So that's why we have to use the same number to equalize this one, to balance this. That means here 2 MnO4 minus and 2 MnO2, because there only the electrons are balanced. Next, balance the oxygen by adding the H2O molecule. So let us see how many number of oxygen atoms are there on both sides. 2 into 4, 8 oxygens on the left hand side. Here 4 plus 3, 7 oxygens on the right hand side. So 1 oxygen is less in the right hand side. So add 1 water molecule on the same side. So that here it becomes the H2O. Now, balancing of hydrogens is not applicable in alkaline medium. Same rule is not applicable. Then balancing of hydrogen. How to balance the hydrogens in the alkaline medium? Very simple thing. In alkaline medium, we have to balance the hydrogens by adding the OH minus ions, not H plus ions. But which side we have to add the OH minus ions? Whichever side more number of hydrogens are there, same side add the OH minus ions. How many number of OH minus ions we have to add? Whatever the extra number of hydrogens are present, the same number of OH minus ions add on the excess side and equal number of water molecules on the opposite side. Example, here 2 hydrogens are present, this side there is no hydrogens. Means extra hydrogens are present only on the right hand side. This is the alkaline medium, so that we have to balance using only OH minus ions. So according to the rule, add the OH minus ions on the excess side only. So I am adding the OH minus ions. How many OH minus ions we have to add? See here 2 hydrogens are there. Means 2 hydrogens are extra on the right hand side. So that add the 2 OH minus ion the extra side and equal number of water molecules on the opposite side. That means 2 water molecules because we added the 2 OH minus ions on the that side. So now cancel the water molecules 2 and here 1. So that 1 water molecule is present. Now the equation can be written as 2MnO4 minus plus Br minus plus H2O gives 2MnO2 plus BrO3 minus plus 2OH minus. Now let us apply the last one, means checking of the charges. See 2 negative charges and here 1 negative charge. Total 3 negative charges on this side. Here also 1 and this is 2. Total 3 negative charges on the right hand side. Let us check the other elements also. 2 manganese, 4 into 2, 8 plus 1, 9 oxygens. Here 4 plus 3, 7 plus 2, 9 oxygens. And hydrogens, 2 hydrogens and 2 hydrogens. So 1 bromine. So all atoms along with the charges are balanced. So the reaction is balanced. Now let us see the how to balance the redox reaction using the ion electron method or half reaction method. Half reaction method or it is also known as ion electron method. Let us take an example so that rules and balancing both can be discussed in acidic medium as well as in the basic medium. So the question here is, balance the following redox reaction in acidic medium using the half reaction method. Anyhow, we are discussing about the half reaction method only. So the given reaction is Cr2O7 2 minus reacts with Fe2 plus and oxidizes Fe2 plus into Fe3 plus plus Cr3 plus. Chromium dichromate ion is reduced to the Cr3 plus. So what is the first rule here? The rules are little bit different from the oxidation number method. Here only for 1 or 2 rules, so starting rules are same. Afterwards we go in the reverse manner of the balancing of these reactions. So first one is, assign the oxidation state of every atom in the given redox reaction and divide the equation into oxidation half and reduction half. So we have to assign the oxidation state of every atom. So chromium in dichromate is +6, oxygen is -2. Anyhow, iron is given +2. Here iron is given 3+ and chromium also given 3+. Afterwards, we have to identify which part of the reaction undergo oxidation and which part of the reaction undergo reduction, and we have to split the reaction total equation into two parts. One is oxidation half reaction and second one is reduction half reaction. So let us see here, chromium oxidation state decreased, so that this is the reduction part. Iron oxidation state increased, so this is the oxidation part. So I'll write down this side. Oxidation half reaction and reduction half reaction. Oxidation half reaction is iron is oxidized, so that here Fe2 plus oxidized to the Fe3 plus and dichromate ion is reduced. Cr2O7 2 minus converted to the Cr3 plus. So this is a step 1. Then what is the step 2? Balance the elements other than oxygen and hydrogen. So now we have to balance the elements other than oxygen and hydrogen. So irons are already balanced. Write down as it is. Fe2 plus converting into the Fe3 plus. So not necessary to balance. Here chromiums, 2 chromiums are present, here 1 chromium is present. We should not balance the oxygens and hydrogens. Other than oxygen and hydrogen, we have to balance it. So Cr2O7 2 minus converts into the 2 Cr3 plus. And next one. Balance the oxygen by adding H2O molecules. So interesting thing here, no oxygens and not necessary to balance this one. As it is, write down once again. Fe2 plus Fe3 plus. But there, this half reaction has to be balanced with the oxygens, because the left hand side 7 oxygens are there, right hand side there is no oxygens. So that here we can write down that Cr2O7 2 minus converts into the 2 Cr3 plus plus 7 water molecules. And next, rule number 4, balance the hydrogens by adding H plus ions. So H plus ions we have to use it here. Here not necessary. So again write down the same. Fe2 plus converts into the Fe3 plus. Here 14 hydrogens are on the right hand side, but left hand side there is no hydrogens. Add 14 H plus ions on the left hand side. So the reaction becomes Cr2O7 2 minus plus 14 H plus giving 2 Cr3 plus plus 7 water molecules. So next one. Equalize the charges. So before the equalize the charges, balance the charges by adding electrons. So we have to balance the charges on every half reaction just by adding only electrons. Here 2 positive charges are there, here 3 positive charges are there. So we have to add electrons. On which side? Whichever side more positive charge is there, that side only we have to add the electrons. And how much we have to add means the difference of the positive charge values we have to add. One extra positive charge is there, add 1 electron that side. So that 1 electron will neutralize the 1 positive charge and remaining 2 positive charges, 2 positive charges, so that balanced. So Fe2 plus gives Fe3 plus electron. And here, see 2 negative charges, 14 positive charges. So 12 positive charges are this side. Net positive charges are 12. This side 2 into 3, 6 positive charges. So net positive charges, that side 6 positive charges, this side 12 positive charges. So 6 extra positive charges are present on the left hand side. So add 6 electrons this side so that 6 electrons will neutralize the 6 positive charges. So both sides 6 positive charges we shall remain. So that here we can write down that Cr2O7 2 minus plus 14H plus 6 electrons gives 2 Cr3 plus and 7 H2O. Next one. Equalize the electrons in both half reactions and combine them. So let us equalize. That means the number of electrons in this reaction must be equal to number of electrons in the other side of half reaction. So for that purpose, we need to use certain numbers to multiply it. So this reaction has to be multiplied with 6 to get the 6 electrons. So the equation becomes 6 Fe2 plus gives 6 Fe3 plus 6 electrons. That reaction as it is. Cr2O7 2 minus 14H plus 6 electrons gives 2 Cr3 plus and 7 H2O. And remaining part is combine them. So we have to combine the both half reactions. Why? Because in the starting step we split this given reaction into half reactions. Again we have to combine these two half reactions. So while combining, all reactants must be on the reactant side and products has to be written on the product side from both half reactions. So the reaction now becomes, see the reactants 6 Fe2 plus Cr2O7 2 minus plus 14H plus 6 electrons gives, now products 6 Fe3 plus 6 electrons plus 2 Cr3 plus 7 H2O. Now cancel the common species. 6 electrons cancel out and there is no other common species to cancel. So that write down the remaining reaction, that is 6 Fe2 plus Cr2O7 2 minus plus 14H gives 6 Fe3 plus 2 Cr3 plus 7 H2O. Now let us finally check whether the reaction is balanced using both elements as well as the charges. 6 iron, 6 iron. Irons are balanced. 2 chromium, 2 chromium. So chromiums are balanced. 7 oxygens, 7 oxygens are balanced. 14 hydrogens, hydrogens are balanced. Atoms are balanced. Now let us see the charges. 6 into 2, 12 positive charges plus 14 positive charges. Totally 26 positive charges and 2 negative charges. That means 24 positive charges are on the left hand side. and 6 into 3, 18 positive charges, and 2 into 3, 6. 18 plus 6 equals to again 24 positive charges. So both sides the positive charges are also balanced. So the reaction is now balanced. So now let us see the alkaline medium instead of acidic medium. All these rules are same except, as I said, balancing of hydrogens only differs from acidic medium to the basic medium. So now let us see the basic medium also. In basic medium, so let us take the reaction. MnO4 minus plus iodide ion changes to the MnO2 plus I2. So this reaction we have to balance in the alkaline medium. So all rules are same except this balancing of hydrogen differs. So let us see the first rule. Assign the oxidation state of every atom in the given redox reaction, and afterwards we have to divide the reaction into oxidation half and reduction half. Manganese oxidation state +7, oxygen -2. Anyhow, iodine is given as -1. Manganese +4, oxygen -2, iodine is equals to 0. So now let us divide this equation into two equal parts. Oxidation half reaction and reduction half reaction. So which is oxidized? I minus, oxidation number increased from minus to the 0. So let us write down that particular part here. That is I minus changes to the I2. And reduction half, +7 to the +4, the value decreases. So this is decreased. MnO4 minus changes to the MnO2. Apply the second rule. Balance the elements other than oxygen and hydrogen. So we have to balance the elements in both half reactions other than oxygen and hydrogen. Two iodines are here. Here only one iodine is there. So balance it. 2I minus gives I2. And here MnO4 minus gives MnO2. See, whenever we are applying the rule, I am writing the reaction again and again. So here next one is balance the oxygen by adding the H2O molecules. Here no oxygens, not necessary to balance, but even though we have tried it down. Here 4 oxygens, that side 2 oxygens, add 2 water molecules on the other side. So I'll write down this reaction first. 2I minus gives I2. Here MnO4 minus gives MnO2 plus 2 water molecules. Next one is balancing of hydrogens. In acidic medium, we add the H plus ions, but we are using the basic medium. So this cannot be applicable here. So balancing of hydrogens in alkaline medium is done just by adding only OH minus ions. Just like in the earlier oxidation number method, here also we have to add the OH minus ions only on the hydrogen excess side. And how many number means whatever the number of extra hydrogens are there, same number of OH minus ions we add on the hydrogen excess side and equal number of water molecules on the opposite side. So here not necessary to balance because there is no oxygens or hydrogens. 2I minus gives the I2. Look at this side here, 4 hydrogens are there. This side there is no hydrogens. Add 4 OH minus ions on the right hand side and 4 water molecules on the left hand side. So MnO4 minus plus 4 H2O gives MnO2, 2 water molecules and 4 OH minus. Look at this side, this cancel out completely. It gives 2 water molecules. So that 4 and 4 hydrogens. Next one, balance the charges by adding only electrons. So we have to add only electrons. 2 negative charges are this side 0. So that add 2 electrons that side. Each electron brings 1 negative charge. 2 electrons together will give the -2 charge. So that here it is 2I minus gives I2 plus 2 electrons. And here 1 negative charge, here 4 negative charges. So add 3 electrons this side. MnO4 minus plus 2H2O plus 3 electrons gives MnO2 and 4 OH minus. Next, equalize the electrons in both half reactions, afterwards combine them. Here 2 electrons are there, here 3 electrons are there. Both electrons must be equal to each other. So that multiply with opposite numbers. Why? Because this is even number, that is the odd number. So multiply this equation with that number 3 and multiply this equation with this number, that is equals to 2. So write down the equation 3 into 2. 6I minus gives 3I2 plus 6 electrons. Here 2MnO4 minus plus 4H2O plus 6 electrons gives 2MnO2 plus 8OH minus. Next, combine these reactions. We have to combine the reactants on reactant side and products on the product side. So that here 6I minus plus 2MnO4 minus plus 4H2O plus 6 electrons. Now both products 3I2 plus 6 electrons plus 2MnO2 plus 8 OH minus. Now cancel the common species from both sides. Here 6 electrons and 6 electrons cancel out, and there is nothing to cancel, water molecules that side not there, so that this is the balanced equation, so that we shall write down that 6I minus 2MnO4 minus 4H2O gives 3I2 plus 2MnO2 plus 8 OH minus. Let us final check whether the reaction is completely balanced or not. 6 iodines and 6 iodines, 2 manganese, 2 manganese, and 8 hydrogens, 8 hydrogens, oxidants. 2 into 4, 8 plus 4, 12 oxidants this side, 8 plus 4, 12 oxidants, negative charges. 6 and 2, 8 negative charge this side and 8 negative charges the other side, so that the reaction is completely balanced. Now let us see another type of reaction, that is the disproportionation reactions. How to balance the disproportionation reactions? Balancing of disproportionation reactions. So let us see how to balance the disproportionation reactions. Usually in disproportionation reactions, we know that only one element participates both in the oxidation as well as in the reduction. That means the same element or the molecule is the reactant molecule for both of the products. So let us take one reaction here. P4 disproportionates into PH3 and H2PO2 minus. So we need to balance this reaction in alkaline medium. So first of all, let us assign the oxidation state. Here phosphorus oxidation state is 0, here it is -3, here it is equals to +1. So usually balancing of these disproportionation reactions using the oxidation number method will confuse us. Actually, we can balance these reactions using both oxidation number method as well as the ion electron method. But whenever you are using the oxidation number method, same P4 molecule means same reactant molecule we have to consider as a reactant for both of these products. So it will confuse us to consider the same reactant molecule 2 times for the balancing of each of the products. So let us try to divide this equation into the oxidation half reaction and reduction half reaction. Using the ion electron method, we shall balance it. So here, from here to here, it is reduction reaction, and from here to here, phosphorus is oxidizer. So we can take that oxidation half reaction and reduction half reaction. So we shall write down the both of these half reactions in which the same P4 is the reactant molecule. So oxidation half reaction, P4 gives H2 PO2 minus, whereas reduction half reaction, P4 gives PH3. So in ion electron method, we have to balance the elements other than oxygen and hydrogen. So here 4 phosphorus are there, here only 1 phosphorus. So first of all, you have to put 4 here. And here also 4 phosphorus are there, here only 1 phosphorus. So that balance the elements other than oxygen and hydrogen. Now let us try to balance the oxygens by adding only water molecules. So here 4 into 2, 8 oxygens are there. So add 8 water molecule this side. So P4 plus 8 H2O gives 4 H2 PO2 minus. And in this case not necessary because there is no oxygen, so that we can write down as it is. P4 gives 4 PH3. Now balancing of the hydrogens. See here 8 into 2, 16 hydrogens are on the left hand side. 4 into 2, 8 hydrogens are on the right hand side. In alkaline medium, we have to balance the equation by adding only OH minus and that too on the excess side. So here 16, here 8 are there. So 8 extra hydrogens are present this side. So you add 8 OH minus on this side and 8 water molecules on the opposite side. So we get P4 plus 8 H2O plus 8 OH minus gives 4 H2 PO2 minus plus 8 water molecules. And in this case 12 hydrogens are there. So add 12 OH minus that side and 12 water molecules on the opposite side. So P4 plus 12 water molecules gives 4 PH3 plus 12 OH minus ions. Now balance the charges by adding the electrons. Here 8 negative charges, here only 4 negative charges are there. So add 4 electrons that side. So we get P4 plus 8 H2O plus 8 OH minus gives 4 H2 PO2 minus 8 H2O plus 4 electrons. And in this case 12 negative charges this side, but this side nothing is there. So add 12 electrons this side. So we get P4 plus 12 H2O plus 12 electrons gives 4 PH3 plus 12 OH minus ions. Now equalize the electrons in both reactions. Here 12 electrons are there, here only 4 are there. So multiply this equation with a suitable number, that is 3. So that we get here 3P4 plus 24 H2O plus 24 OH minus gives 12 H2 PO2 minus plus 24 H2O plus 12 electrons. Anyhow, that reaction is already balanced. So now combine both the reactions, means reactants on reactants and products product side. So I'll write down the same equation here. So P4 plus 12 H2O plus 12 electrons gives 4 PH3 plus 12 OH minus. So now let us try to cancel the common species here. Here 24 H2O, here also 24 H2O are there. Here 12 OH minus, here 24 OH minus, balance is 12 OH minus is present. And here 12 electrons cancel out. So let's write down the remaining part here. 3 plus 1, totally 4 P4 plus 12 H2O plus 12 OH minus gives 12 H2 PO2 minus and 4 PH3. See here, we can simplify this equation further using the fourth table, so that you can say that it goes one time with 1/4, it goes three times, and one time. So that equation is now P4 plus 3H2O plus 3OH minus gives 3H2PO2 minus plus pH3. So let us try to check the equation once again. 4 phosphorus on the left side, 3 plus 1, 4 phosphorus on the right side, 3 into 2, 6 plus 3, 9 hydrogens, 6 plus 3, 9 hydrogens, 3 and 3, 6 oxygens, 3 into 2, 6 oxygens, 3 negative charges, 3 negative charges. So the reaction is balanced. So in this way we can balance the disproportionation reactions. You can balance the disproportionation reactions even using the acidic medium also in the similar method, where only there is a difference in the balancing of hydrogens. Dear students, I hope you understand this class. Please do share it with your friends, and please do not forget to subscribe the channel. Thank you one and all.